The broadcast is now starting. All attendees are in listen-only mode.
Hi, everyone, and welcome to the Autodesk Build Your Simulation Moldflow IQ webinar series. Thanks again for joining us today. I know this one was a little short notice, but future ones will be a little bit more regular on a monthly basis for these webinars. Before we dive into any topics, or today's topic, I'd like to review a few logistics with you all. First, we have an hour time slot booked for us today. However, the intent is to present during the first 30 to 40 minutes, and then we'll take the remaining time for live questions and answers. Throughout the webinar, you may enter your questions into the GoToWebinar's questions interface box. And we do have some panelists on the line here that are going to be helping me today. Any questions that we cannot answer during the webinar, we ask you to please post these within the Moldflow Insight forum, and either myself or one of the other experts can help with answering. This webinar will be recorded, so if you do have to cut out, we will be sending this to you all after the webinar today, and then we will also be posting it to the simulation community website shortly after the webinar. Now let's get into some of the good stuff. Today we'll be reviewing how to utilize Moldflow Insight towards investigating and resolving issues in existing injection molding processes. As a quick introduction, my name is Kristen Kilroy, and I am a plastics engineer who has worked with Moldflow for about 6 years now at Autodesk. Beginning on the technical marketing team or technical support team, I probably did interact with a few of you, so it's great to see some of those names pop up here on this webinar. Currently, I'm actually on the simulation marketing team, performing both technical and product marketing for Moldflow software, as well as our other simulation products, Helios and CFD. Here's a brief overview of today's agenda. We'll start with taking a high-level look at, the typical Moldflow workflow. Then we'll jump into the topic of working backwards. What does this actually mean, and why would we need to work backwards towards getting some good, high-quality parts out of your existing molds? We'll run into identifying the cause using Moldflow and simulating that exact process, and then jump into finding the best solution for resolving that issue that you're seeing at the press. Once that solution is found, what do we do next? So we'll cover a few tips on how to take those results into actually implementing them. Then we'll do a quick wrap up and then follow with some live Q&A. Okay, so when we look at Moldflow software, one of the things that we on the Moldflow team always advise is to use the software early in the design process. This is ideally because the software can help to prevent many molding issues before the first cavity is cut. We all know this. As we can see here, we can say to start using Moldflow at the part design stage, where you can gain insights for things like design for manufacturing, will the part fill, and even weld lines due to design as some examples. But you can also follow those by running Moldflow simulations for the mold design and process optimization steps. So realistically, simulation plays a part in almost each of these stages. As with any project, the more time you invest into it, the more costly changes are later on, often growing exponentially as shown here. So obviously it's going to cost more to take an existing tool back into that product design phase or the mold design phase. So ultimately, the goal is to use simulation towards minimizing the time and costs during these stages. However, being realistic, we know that pressures to speed through the design process and to start manufacturing and selling parts can cause these steps to be fast-tracked or even skipped. And since you very rarely see the exact same part that has fail-safe design, environment, and processes, unfortunately, many of those instances may result in troubleshooting at the press. Speaking from experience, I know this to be true, especially in cases where molds are transferred between manufacturers. Acquiring legacy injection molds bring in a whole new level of troubleshooting needs, with not always being given the full history of the tool or its tricks to be able to manufacture consistent high quality parts. On those legacy tools, and those tools that may have been fast-tracked through that design phase, this is where you may need to use Moldflow in a different way than the ideal workflow I just talked about. Using Moldflow in order to work backwards through the design of the part, tool, and process in order to address issues that you see within the parts your tools are already manufacturing. So we can see here, this is just a sample scenario. We need to push the schedule up 2 weeks. I've experienced it when I was working in industry. I know many of you experience that every day, where something comes up and we have to cut the time. So this is hopefully going to help with that, incorporating some sort of simulation into your workflows. So after identifying that there is an issue that needs addressed, how do you even start investigating it within Moldflow? The first step before doing anything within the software is actually to understand what you want to get from Moldflow. For example, let's say a legacy tool that you've acquired is just out of tolerance after molding the first few shots after receiving it. Measuring the cavity, the dimensions appear to align correctly to the technical drawings. So when looking into conducting a Moldflow simulation, you may want to use the simulation to understand cavity filling and find exactly what is causing excess shrinkage and warpage. Then, you might want to utilize Moldflow to review scenarios of how to approach resolving the causes through process optimization first, instead of jumping into having to make costly and time-consuming steel changes. Identifying this will help tremendously when getting into actually setting up the simulation within Moldflow. So once you have an idea for what you're looking for Moldflow simulation to help with, the next step is to mimic the existing process. So you have a baseline to compare your experiments to. This can sometimes be a little tricky, as sometimes the settings may need some work to fit them into simulation, such as converting different units. And you'll hear me mention units a lot because that's something I remember from the support team often hearing. Some things to keep in mind when setting these up are to first confirm the CAD geometry changes, or the CAD geometry actually matches the tool geometry. So verifying thicknesses, identifying the built-in steel shrinkage percentages, and making sure all the part features actually match what are in the mold. Sometimes different iterations of CAD drawings can get misplaced, so measuring it firsthand to match to your simulation is always the best bet. Modeling, or next to confirm the gate location and all the other feed system components. So dimensions, the type of feed system, such as hot runner or valve gate, and the overall design should match the actual tool. Modeling the cooling system to correctly simulate cooling's effect on the molded part is also critical. If complex, you can also consider modeling this within CAD if you don't have the original CAD files for it, and then you can import it into Moldflow. And finally, modeling the mold boundary adds additional accuracy into the simulation by providing a better guesstimate of the actual mold size within Moldflow. And this is in the case of when you might not have the mold block model that you would want to import in Moldflow instead. The next step is to confirm material used for Moldflow and make sure it matches exactly what you're using. So within Moldflow, there are preloaded databases that have measured materials in it. So making sure that that measured material matches the material that you're using at your press, that is key into replicating it within Moldflow. And this also includes mold materials as well as part or mold inserts too. So once the model is set up, the process settings need to be changed to match the molding process. Once again, this is where you really need to keep an eye on those units, because typically you might be referencing either a mold trials process setup sheet or screen printouts, which could have different units from what Moldflow is using inside the solvers. Moldflow Insight contains several options for customizing the molding process for improved accuracy when comparing the simulation to actual manufactured parts. As you can see here are a few screenshots of those process setting dialogues. Starting with the basics, let's remember a few slides back when I mentioned that how helpful it is to know what you're trying to get from Moldflow. And this is because we look at the screenshots here where it's updated to match the input analysis that you call out in the beginning. So we looked at that example where shrinkage and warpage issues cause a part being out of tolerance. This means that Moldflow simulation must include a cool, fill, pack, and warp analysis, as this will provide a wider range of results to help the analyst find the cause of the excess shrinkage and warpage, since cooling and flow can both affect it. After specifying the analysis, the process settings update to match those relevant inputs as mentioned. So we can see here it's got 3 pages on the left-hand side here. First is the cool settings, next is fill pack warp or filling pack settings, and then it's followed by the warp settings. Aside from general settings, such as the fill controls and pack profiles, entering in advanced solver settings opens up options for adding things like machine type, core shift analysis, and even mold venting analysis settings. The best method for making sure everything matches correctly is methodically comparing these settings to your trial process setup sheets, because then you won't miss a beat. With these settings entered to match your mold trial, you are not able to compare apples to apples when taking this original analysis and modifying it to find the resolution for the part quality issue that you originally stated. Once this simulation runs, the results should match very closely to those seen at the press. If not, then take another look through the study settings for any differences. And that would be through these process settings as well as the model itself. As something that seems minor could influence a huge difference in the long run. Now, once you validate the study against what you're seeing at the press, you can then start looking at results for those insights into finding a feasible solution to resolve it. One thing I really suggest is to keep Moldflow help documents open as you're running through the results. As you can see here, it not only describes what the result is technically displaying, the help documents also share insights to what you should see for what you should look for and provide some suggestions on actual causes and resolutions to those. The result that will be helpful for you in the long run really depends on what issue you're trying to resolve. Again, circling back to that initial statement of making sure you know what you want. If we look at that out of tolerance part that we mentioned, we know that shrinkage and warpage can be caused by a number of things. So we can jump right into the warpage analysis. However, having a quick look at the fill time, part temperature, volumetric shrinkage, and pressure at the end of fill result plot can also be helpful in just giving you a background for that warpage result. And I know many of you may be familiar with it, but there's also a setting when initially running the analysis right before you hit the warpage results, but you're able to select a setting that goes into the main causes of deflection. And Moldflow uses the word deflection because it incorporates both shrinkage and warpage in it. So causes of deflection that it can pick up on using this setting would be differential cooling, differential shrinkage, and orientation effects, which help to identify the main cause so you can start identifying options for reducing deflection in the long run. Now, with the possible causes identified from preliminary inspection of the original Moldflow study that you created, based on the steps that I gave you previously, there are a few ways that you could approach actually testing and validating a solution within Moldflow simulation. The first option is to copy the study and make manual modifications to it, being mindful not to make too many changes so you are still comparing apples to apples, as mentioned. This option is ideal if you already know a direction that you want to take resolving it, or there may be restriction with including it in the other option, the automated experiment that I'll discuss shortly. For example, if you know you need to modify the gate location of an analysis or of a mold, you can use this method, the manual method that I mentioned, to change it in there and compare it to the original analysis. This can also be done for cooling designs or even material changes. The alternative option is to set up an automated design of experiments or parametric design or parametric analysis, where you enter in the variables and quality concerns that you're interested in. And then Moldflow creates several variations of your analysis automatically when you run the simulation. Going this automated route results in the summary table and can include visual graphs depending on what analysis you run that aid in interpreting the effects of each of those changes, and as a result enables the analyst to identify if the original issues you were investigating are in fact able to resolve through changing process settings or modifying wall thickness or even feature placements. Now, Moldflow Insight does have the ability to perform other automated tasks through scripts and macros. So the time required to set up those manual experiments of that first option could be reduced, thus providing great options, or thus providing both of these as great options for experimenting within Moldflow for your specific case. After digging into the results and you find one or a few good options to minimize or eliminate part quality issues, it's time to circle back to your initial molding trial. If the solution is to change process settings, this would just require pulling those influential process settings to enter it into your injection molding machine. Again, remembering the units to make sure they match up. If there are tooling changes needed, the best case scenario would be to work with your tool designer or tooling engineer to see how to efficiently and cheaply make those adjustments to the steel. You may need to actually work with them on the costs associated to making those changes and make sure they're justified before investing into that. Because sometimes a new mold could potentially be cheaper. I know molds are expensive, however, some changes could be expensive as well. Even exporting the modified plastic CAD part from Moldflow to send them to your tooling designer or whomever is a way for them to understand exactly what is needed to push forward with the changes. With the efforts put into matching the analysis initially, all those other steps that we walked through a few minutes ago, the result of your molding trial can be that much closer to predicting these fixes will actually help to improve the final part. Now, we did run through this a little quickly today, so here's the key takeaways from what we discussed today. Essentially, prep work is number one priority. Knowing what issue you're really looking to resolve helps to lead through the map within Moldflow. So you're taking which analysis you want to select, as well as going into the results that you're looking at, and even running into possible scenarios for solving those issues. The first analysis must be identical to what you're actually molding. Otherwise, all those other simulations that you may run in the future would be skewed. Next, understanding the results. So being able to interpret what Moldflow is actually outputting to you and being able to understand how to use those is critical as well. So I mentioned the help documentation. Be sure to keep an eye on that. For any of the result plots, each of those have their own dedicated page within that help documentation that leads into all of those what to look for, as well as potential causes and resolutions for them. Next, know your project constraints. Are you able to actually make those changes that you found could resolve that issue? Or is it better to start from scratch? You might need to work with your whole team on that to understand what restrictions you have in the long run before actually implementing any changes in the trial. And then finally, leading into an actual molding trial, for the simulation to actually be validated, we want to actually test it within the mold. Again, it will be a little bit more difficult and time consuming if you do have to make those tooling changes or even material changes, because sometimes materials do require some tooling adjustments such as draft or shrinkage. But running a molding trial for, say, process setting changes to optimize your part quality is kind of a no-brainer when it comes to trying to troubleshoot and fix things quickly. So Moldflow is just a sidestep that you can take while you're still either molding with that mold, or else maybe have it set on the mold shop table and waiting for a go, no-go signal. And that is all I have for you guys today. As mentioned, we'll go through some live Q&As, but before we jump into that, if there are any questions on the line here, I do want to mention again, if you don't get your question answered today, you can always go to the forums and we'll be happy to jump on there and answer those for you. And then alternatively, if you do want to rewatch this webinar or share it with others, we'll be posting this to the simulation community page, and you can see the link listed down below there. Okay. All right, then with that, I do appreciate everyone's time here today. As mentioned, please do follow up on the forums. Our next webinar will be later on this month, and we will send out an email notification to everyone who attended here today with the recording from today, as well as the date and topic and additional details for that webinar. If you do have any questions, feel free to post to the forums. And again, thank you all for your time and enjoy the rest of your days.